everyone, in this video I want to talk to you about a few options for communicating the results of your work in computational social science. Now, communicating can mean a lot of things. We can create PDFs, we can create websites, we can create apps, we can create presentations, and RStudio has some really great options for all of those, and I'm also going to tell you about one other open source tool that will be really useful in communicating your work. Okay, so within RStudio, mostly through my previous tutorials, we've been creating .r scripts, you might have noticed. But there's a lot of other options here. You can see we have Markdown and Shiny Web App. So let's go ahead and begin by taking a look at the Markdown. A Markdown file is simply a way of creating an attractive document that can kind of seamlessly integrate images, web links, and things like that. So let's go ahead and give it a name. And now we can choose a few different options. We could choose to create an HTML file, which would create something like a web page. We could create PDF, and that would create more like something that looks like an academic article. And you also notice we have some other templates in here. All over the internet, there's great templates for our Markdown documents for specific journals or specific types of web pages. Those are a bit more advanced topics, so let's just stick with an easy example where we're just going to build a single PDF file. Okay, so now you see that R has created this kind of default style Markdown document for me. I want to show you what it looks like first, and then we'll step back into how it gets made. If you look up here at this button that says knit, knitting means compiling or taking the code that is the kind of the guts of this document and producing the kind of beautiful output. So if I click out, if I click knit, it's going to create this file, and eventually it's going to open as a PDF file. So you can see up here I've got my title, author, date, and if you've seen a lot of preprints in the social sciences, this kind of format might look a little bit familiar. So you can see here we can have titles, and then as we kind of zoom in a little bit more here, you can see we can have kind of code chunks that let us communicate our code. Most of the time we wouldn't want to do that, but sometimes we might if we want to show people exactly what we did. And then we can have output, everything from the output in the console to the output in the viewer pane. Now, as we go into the actual guts of the R Markdown file itself, we can see here that we have a lot of different options. I already went over the title and author. We could have specified HTML here to produce a HTML document instead of a PDF document. But first thing I'd like you to take note of is these kind of code chunks. So every time we have these three little marks, and then everything in between those three little marks constitutes a code chunk. Here we specify the language, R, and then a couple of options. I'll go over a little bit more about what those mean in just a minute. But for now, what it's saying is that the default option is whatever you write in these code chunks should be outputted in the actual document. If you want to change that, you can set echo equals false here. So now you'll see we have our first title. In Markdown, there's a lot of different conventions for aesthetics, how large the font is, and so on. And typically these hashtags are used to create different levels of headings, different sizes and subheadings, and so on and so forth. So if you remember from the document I just showed you, the title was R Markdown. Here we can see how we add a web link with these carets. If we put words in between these kind of two asterisks here, they become bolded. If we use single asterisks, they become italicized. And here you can see some of the output that's being done in this document. So next I want to tell you about Prezi. Prezi is another format for creating presentations. Let's take a look. Let's go up to File, New File, and this time let's select our presentation. Now, as you'll see here, this presentation has opened up in this presentation pane on the upper right hand side. If I change my title, my slide will change in real time. And these little arrows at the bottom of the screen allow me to advance through the screen. Now, the syntax of the code that makes these Prezi presentations is very similar to the Markdown format. There's many tutorials online that you can follow. The main thing you want to know is slides are separated by these equal signs here. And if you don't like the look of these slides, you can add your own custom CSS to change color and play with a lot of different variables as well. There's some examples on my GitHub site if you'd like to check that out. Okay, next I'd like to show you what Shiny is. Shiny is a really cool tool within RStudio that allows you to create an app right inside RStudio. So we're going to do a really simple toy example here called My App. To put an underscore in there. And you'll see here we've got code just like we had for Markdown in our Prezi. And we've got a Run App button here. So once again, let's run the app, take a look at it, and then we'll work back and see what it does. So this is a toy example within RStudio. We've got a histogram here of the frequency with which the Old Faithful geyser erupts, which is a natural water geyser in the western United States. And here all we're simply doing is moving this slider and seeing how it changes the distribution in the histogram, right? Obviously not very useful for many purposes, unless maybe teaching and, I don't know, showing people how histograms work. But where Shiny really excels is that there's a massive kind of community of people who share the code to produce much more sophisticated Shiny apps, so apps that might grab Twitter data, visualize it, analyze it, even do certain types of analyses on data. And so it's a really great tool to get to know. As we look through the code here, I just want to note briefly, I won't go into it deeply, but basically you're going to have two parts of a Shiny app. The first is called the UI, or user interface, and that's kind of what the user's eye sees. So we create things like a slider or a image, and there's a lot of tutorials for Intro Shiny that would get you some examples, or you can begin by working from someone else's example and then tweaking it to make it your own. And then finally, in the second part of the Shiny script, there is the server part of the script. And the server is really kind of the brains, the calculation, what's being done, not what the user is seeing, but what kind of routines, functions, or applications might be going on under the hood. Okay, lastly, I'd like to show you an alternative to RStudio for working with kind of beautiful documents. So we've already gone over Markdown. That's a nice format 9 times out of 10, but some journals require that you submit using LaTeX. LaTeX is a format for creating nice looking documents. It also has some advantages for example, using a lot of Greek in your text, and maybe above all signaling, right? Showing that you know this fancy thing to make these fancy documents. Now that's a bit obnoxious, but there is another useful part of LaTeX, which is that it makes your documents easily reproducible, and you can indeed embed some of your code sometimes in the documents themselves. And so each time you have to iterate, it makes it that much faster. If you're collaborating with other people, it makes it a little bit faster too. Now there's lots of different ways to work with LaTeX. My current favorite is an online interface called Overleaf. So here what you can see is a recent article that we published in my lab. It's in the format of the Proceedings of the National Academy of Sciences, which has particular, headings it uses and conventions about the bibliography and different types of graphics and so on and so forth. And just like the Markdown document that we started with, you can begin with a template. So there's templates for many different journals. And when you open the template in Overleaf, you'll see this pane, which has all of the code that you're going to be editing. And then when you hit recompile up here, it will produce a copy of the document that you're working on. If you want to download it, you click here. And really from there, it's about learning LaTeX and the kind of strange ways that things are done. And typically speaking, one needs to learn different types of syntax and format for example, everything from how to define an author in a document, to how to italicize something, to how to remove a watermark. There's a lot of different stuff, but really with some creative Googling and a little bit of persistence, many people can get good results with this very easy to use tool. Now, why would a computational social scientist want to learn about GitHub? Isn't GitHub just for people kind of developing software applications? Does it really have that much application for those of us who aren't, say, building software or apps? The answer, I think, is yes. So let me tell you some of the reasons why you might want to use GitHub. You probably already have a kind of file management system. Hopefully you have something like Dropbox or Google Drive to back up your files and kind of keep track of things and access them in different places. And that's great. But very often when we make changes, we have trouble kind of figuring out which version was which changes we made before which version. We can only get so kind of precise with the titles we give to the different versions of files. And GitHub is kind of more like track changes in Word, where you kind of highlight and edit, and then other people can make edits. You can see their edits and eventually kind of decide whether to merge them together. GitHub is kind of like track changes, but with files, and in our case, mostly .r files. Okay, or maybe Markdown files or whatever. So one, GitHub provides you with a way of keeping track of your code, seeing when it evolved and how it evolved, and kind of going back in time and finding an earlier version of your code. But second, GitHub makes it a lot easier to work with other people's code. So it provides ways to kind of instantaneously bring someone else's code onto your machine in a very convenient way so that you can kind of tweak it to serve your purposes. Eventually, when you become more skilled yourselves, you may be sharing your own code with others, and GitHub provides another great way to do that as well. But on top of that, GitHub is usually where a lot of the newest kind of releases of R packages and softwares happens. And there's really good discourse and dialogue on GitHub about how to fix packages, how to tweak them to make them better. So the sooner you kind of learn your way around GitHub, the better. It might not seem like the most immediate or urgent skill to learn, but I promise you, future you will thank you for investing a little time. And it really doesn't take too much time to wrap your head around some of the basic concepts. Okay, just like we began by installing R and RStudio, Git and GitHub are kind of two separate things. So Git is kind of some actual software that's on your computer. You either have to install it on Windows, you can do a quick search for Git Windows, or on a Mac, it comes packaged with something called Xcode, which is a group of add-on functionality features to your basic operating system that software developers need. Once Git is on your computer, you need to interface with Git in some way, and many, many people use GitHub. So let's take a look at what GitHub looks like. So I'm logging on here. You'll see this is me up here. I have these things called repositories. These are things that I built. Here's a website for a class. Here's an R package I made. Here's some other ongoing research, right? And here's some updates from my collaborators, right? Now, what do we want to do here? Well, suppose we wanted to kind of go into my R package here. We can see it's hosting, a lot of different stuff. Some of this might look a little confusing at first, but as you can see here, we've got some .r files. These are actually the .r files that you would use if you install this package. And anytime I make an edit, it can be kind of quickly reviewed and analyzed by others. Okay. But in most cases, you're not going to be writing an R package right off the bat. So suppose you just want to kind of, begin to dabble. Well, maybe one of the first things you might want to do is to create a new repository. A new repository is kind of a place to keep your stuff. And by the way, I'm assuming that you've set up a GitHub account, and that's pretty simple and straightforward. Username, password, you have to verify it. But once you've got your own account, you can just come on over here, come to repos, click new, and now we have to give our repo a name. And I'm going to call mine first R comp soc sci, just to give my viewers or people who view this page some sense of what it might be. And then I'll just say sample repo for tutorial. Now I have to choose if it's public or private. Now, a lot of the time, it's great to make it public, and wherever you can, it's great to share your work with others. On the other hand, maybe this is early work that's not really fit for prime time, or you don't want to share some critical tool you're building for your dissertation. You may wish to choose private. In that case, I'm going to make this one public. Then you're going to be asked a few things that are somewhat counterintuitive. So add a README file. This is simply just like a little note that tells other people what this repository is. And it's kind of an artifact of older versions of working with with GitHub, where you would have a lot of different files, and this was just a quick place to go to figure out what the repo or folder was about. Git ignore is somewhat important. It tells GitHub which files to ignore as it's keeping records of what you're doing. So for example, by default, your computer might save your .r history, which is a kind of file that RStudio produces, in a folder that you're working in. Maybe it's the GitHub folder that you're working in that I'll describe in just a minute. And if that happens, and say you have some sensitive information in your files, the history may capture some of that file. So by default, you may want to add a file called gitignore, and there are many for many different languages, and you would simply choose the one for R and then click create the repo. I'm just going to go ahead and create this one because this is just kind of a simple example. Okay, now that we've created our first repository or repo, which is really just a folder on GitHub, I want to show you how to work with GitHub in RStudio. So if we fire up RStudio here, you'll notice we have just a regular environment here. First, I want to make sure that Git is set up with this computer. If I come over to File and Options here, Preference Options, I see one of my choices here is Git. And I just want to make sure that Enable Version Control is clicked there. Okay, that's great. Next, to start working with Git, I want to create a new project. And we're creating a new project that's basically going to be the Git repo that we just created, this simple folder. So I'm going to go up to New Project, clicked on Version Control. Now I'm going to choose Clone a Project. Cloning on GitHub simply means copying whatever files are up on GitHub onto a specific folder within your computer. So I'll choose Clone here. I'm going to go back to GitHub, grab the URL, paste it back in here. It's given the repo the same name here. And by default, GitHub is usually going to default to something like your Documents folder to create the main GitHub directory. You can change that if you like, but I think most people find that's a convenient place. Okay, so I'll click Create Project, and now we're seeing that RStudio is simply cloning, downloading everything that was in our first project here, especially a file I created called test here. So now that we're in this kind of folder, let's go ahead and try to create something new. Let's say a Markdown file, my Markdown file. And maybe I'll change the title. And now let's say I had done a lot more work and I was ready to create this kind of backup of my work that signifies some milestone in the project, however small, something I wanted to be able to come back to. Well, if you'll notice up here in our environment pane, one of the tabs says Git. And once I save this project here in our GitHub folder here, see it appear down here in our working directory, which is our GitHub folder. If I come up here to Git, you'll see I have a series of things that I can choose. I'm going to choose to upload this untitled Markdown file we just created. And you'll see here this commit button. If I press here, you'll see I get this interface. Now what this interface does is it allows me to see what's different between this file and any previous files. That's often called the diff. The new file would be in green, and the red file would signify an older file. Because all of this file is new, it's all green. And every time I do a commit, which again means making a kind of a milestone that I might want to go back to, some kind of edit. It's usually a more significant group of edits, but maybe it's just one if you're just starting out. And I want to give a message to remind myself what this commit did. So I might say created Markdown file, and now I can simply click commit, and R is telling me about a more convenient way to preclude the need to put in my username and password. But now you can see, if we come over to our history pane here, that we've made one of our first commits to GitHub. Now I want to show you something else here that's an important concept. Now so far we've kind of just assumed you're one person working on one file and just using GitHub primarily for backup purposes and to make it easier to find, places in your code that you need to time travel back to. Now suppose that you're collaborating with one other person, maybe it's your dissertation advisor, or another graduate student, or a software developer, or whatever you do, and they're editing the file at the same time. If they make a commit before you do, you need to pull down the latest version of the repo before you make your commit or push your commit up to GitHub. So this button here will pull the latest version, and of course, since nobody else is editing this file, it says already up to date. And here it says push, which simply pushes up my commits, my edits up onto GitHub, and I'd have to log in here to do that officially. But there you have it. Now if we go back to our GitHub page, we would see that we've created a new Markdown file, just as we described. Now, this is maybe about 95% of the tools that most computational social scientists would want to know. As you progress into GitHub and want to go deeper, there's a few other concepts that I'll cover very, very briefly, just so you know what they are. And these are going to be mostly relevant if you begin to share things with other people. Now, one thing that's very useful is something called forking. So forking means basically taking someone else's repo, but then kind of establishing it as something that you're going to edit or change in some way. Because if someone else owns the repo, you might not be able to make edits. So that allows you to kind of bring a group of files onto your computer and kind of make them your own and edit them. Branching. So sometimes if there are multiple people working on one project, if you were both working at the same time, you could kind of overwrite each other's messages a lot, and you don't want to have to kind of go back and forth. Well, you might create a branch, which is kind of like, think of it as a new part of the project that then gets merged back together onto a main branch. And that's kind of one other way that people collaborate. Finally, if there's a big project, like a big project that lots of different people contribute to, like an open source project, well, if you want to recommend a change, let's say you've discovered some bug and you want to recommend a change, then you might make something called a pull request. And that's a request for whoever owns and maintains or kind of supervises the repository to accept or reject your suggestion. So again, those things are not going to be used by many of you just starting out. I just wanted you to become a little more familiar with the jargon.